Hi, this is your Sapnil Bhartia and welcome to TFR Let's Talk. Today we have with us Ivan Novikov, CEO and co-founder of Wallarm. Ivan, it's great to have you on the show.
Hello, and thank you for having me.
It's my pleasure to host you here today, and this is the first time talking to you. So I'd love to know a bit about the company since you're a co-founder. Talk a bit about when and what problem you saw, because when we look at security or specifically API security, it may seem like a solved problem. It's a very crowded industry. So just walk us through the history lane. When you created the company, what problem you wanted to solve back then?
This company actually was founded and officially we released the first product in 2016 while our inception from the Y Combinator in Silicon Valley. The main idea and the core idea about the product was to actually stop API attacks that actually, that time were at, early beginning of that massive, amount of attack where we are now. So our main idea was to find this attack and stop them, block them in real time. And the main challenge we faced with was, how to detect these attacks because API traffic is, so complex and it's just hard to parse, all this, API requests in real time. So we solved this problem. And the second problem we faced with was very similar. Okay, we can analyze the traffic, but how to block these attacks in real time, right? How to find the most efficient way that actually, large companies can apply that we also solved. And we designed the systems and we built it and start to, roll out this at the commercial rails in 2016.
If you look at the origin of the company, 2016, and just 2 years before that, that's when CNCF was founded, when Kubernetes was contributed to CNCF as an anchor product. And that kind of triggered the whole cloud native movement. Everybody started moving to cloud, which also changed in a way the way we look at security. In early times, before we started cloud native, security used to be someone else's problem. It used to be an afterthought. Now security is becoming a priority. And as we kind of live in an API driven world, there is a lot of discussion around, the kind of threats that API poses and why companies should also embrace API security posture. Can you talk a bit about what is the state of API security, especially looking at your latest API threat state report as well? Where are we?
Sure. And in talking API security, I guess I have to mention a couple of notable events. The first event, you absolutely nailed it, was raising of cloud and cloud native things. And is it for me, I guess, at the turnover moment happened when the Kubernetes start to spreading across the world, because the Kubernetes unlocked this cloud experience for typically not cloud companies, specifically large enterprises. They were too far. I'm talking about industry companies, large, manufacturers, right? They started to adopt this cloud experience in their data centers, right, with the Kubernetes and basically deliver, this cloud native in-house and then, find out the way how to, connect this to the hybrid environments. And it's still, hybrid. This is the first event. So you're absolutely right. The second event is that for me happened literally this year with the rise of AI. So, and then, all this AI, we call this, there is no AI without APIs. In fact, to build anything with AI, you need to feed them, these models by data. And the only way how to get the data nowadays is through the API, right? Very rarely you connect AI to databases, right? You need to kind of collect this data, some kind of like orchestrate this data, build a pipeline. So it's all absolutely driven by APIs. So, and then we have, the second growing factor. Now just API is growing like crazy, the usage growing, and also ultimately security and, security focus to this stuff growing on. That's where we are now. So just to mention, let's say this, years over years, decades over decades, the companies, specifically I'm talking about large enterprises, they build the kind of controls such as isolation controls, different VLANs, data governance, all that stuff. And then overnight, CEO came and told, hey, I need all this data in my AI. So you have to break all your controls and feed the data because you don't have time to build new controls and new security, right? Things. That's from where we get in this problem, right? This emergency, right, that drives basically broken security. Very similar to what happened with, VPN during the COVID, right? Many companies faced with the challenge that, hey, the VPN was in place. It was never designed to serve every single user of every single employee. It was never designed to secure, connection overseas, right? And stuff like that. So the same happened with AI now. But the difference is AI is a topic for the board, like the CEO pushed this initiative into the company, and the security teams, they should not, stand up and tell, hey, no, we don't have security controls ready. We have all these VLANs and data isolations. We cannot grab all the data together in one place. The system was never designed. Our networks were never designed for that. They should do it, and they should do it overnight.
Talk a bit about how are bad actors looking at, the proliferation of AI, that everything is, through API, how they are looking at API as a target, and have you seen a specific kind of attacks that happens? Because we can talk about ransomware kind of things. There are so many, and also bad actors, as I like to say that, as a security guy, you have to be right 101% time. Bad actors have to be right only once. And that's, so which means that it's not a destination, it's a process, not, it's a journey. Security is a journey in a way, which means that, we have to keep up with that. But we also need to understand how bad actors are looking at API, what kind of threats we are seeing.
First of all, just to set kind of like baseline here, right? API is designed to get data accessible, right? API is basically designed to get an access to your data, right? If you break just one control, such as authentication or authorization, the bunch of the data or all of the data became available instantly, right? And when we're talking about all the other attacks, right? Ransomware, exploits, firmware attacks, adware, so all that stuff, they never designed to get attackers into, right? They designed to basically protect the systems, right? That's a completely different world, right? They basically, and it's a big difference and a big shift in understanding what we're doing. Let's say dozens of years ago, let's say, and 10 years ago, 6 years ago, the WAFs, right, web application firewall, secured many websites, and it was kind of enough. But these websites never consumed APIs. And then when this, single page apps and next generation of the website and web development, when the Web 2.0, right, or Web 3.0 start to consume APIs, the controls actually became useless, right? Because they cannot do anything with the data that came and then basically became accessible again overnight because of this, data-driven initiatives. So how attackers say this? So first of all, attackers definitely know how to, find your APIs, because essentially you build it to make accessible, right? And your partners know about this, your customers know about this. The typical way for attackers to start thinking about your, APIs, as we see it during running honeypots and during the reports that we actually bringing together. So we're tracking them for more than like 2 years, 2 years and a half. And before that, we ran the research to cover, all these API exploits for the last, 20 years to find out what was the first one. And so we really know what they're doing. So first thing is obviously they try to find your clients. Your client for your API could be your website, right? If it's a single page app, it consumes API. It could be your mobile app, right? Specifically, if, it's a bank or some, heavily used by mobile devices, right? They unpacking these clients and try to find out how this, clients consume the API. It could be partners. It could be kind of like demo, API, programs or scripts. It could be your GitHub repo, depending on like which kind of business you have. Many companies, specifically fintechs, they have public docs how to consume their APIs designed for their partners and even customers, right? If you're a merchant and you want to connect you with a payment system, the first thing your developers will do is to look at this payment system API. So this is basically public and open and accessible, right? The attackers starting to do the same research on this and try to find all they can, all they can consume there, and then start to build their, test cases, means, testing scenario security tests to find out breaches and then exploit it.
And can you also talk about, if you look at the last couple of years, what kind of exploits are you seeing? What is the mode of payload? What is the made? Once again, the incentive has to be high because it does take a lot of effort. And sometimes, these attackers, sometimes they are state sponsored, they have political motives, sometimes they are just, and there is a big market also to sell credentials and stuff like that. So if you can also talk about the incentives, so because they always look at the low hanging fruits, because that's where the effort is less but the outcome is more. They will not be putting a lot of efforts in just getting. So if you can also talk about the mode of attacks that you're seeing.
Let me start with kind of like statistics. So we call this report threat stats because what we do is essentially get in statistics and also put in place kind of methodologies that everyone can apply and get the same results, right? To make it completely non-opinionated, regardless of our, vendor nature of this report. So it's all available and you can, find the same conclusion. What we did is we download all the CVEs, which is a common vulnerability enumeration kind of codes for this every single, vulnerable product and a particular issue happened there over the, last 30 years to find out what's related to APIs there, and then how this API exploits progress. And so when we just started, it was like 5 or 3 new exploits or new vulnerabilities, a month. Nowadays, we have 5 a day. So that's where we are, right? It's an exponential growth. Why? So first of all, because all the products now have an API. It could be internal API, it could be public API, but all of them consume them. Let's say GitHub, GitLab, all the products that we consume, Kubernetes, basically driven by API itself, the core of the Kubernetes control. So that's all driven by API. It's hard to find any other product nowadays that not consuming APIs, right? And that's why we have that many. The other thing, which is a little bit in the parallel to your point about low-hanging fruits and what attackers is doing, we're also tracking data breaches. So basically, every single time when the data breach happened, let's say it happened to Deutsche Telekom in third quarter this year, and we track them, we find out some details. Sometimes it's just hard, the company's not disclose everything, but sometimes we know details. So and then we try to track. So the main pattern is here. So essentially, it's 2 different patterns. The first pattern is to find an API that directly connect to the data and consume this API because of some issue, such as authentication, authorization, in a very fast way to download an entire database, right? And we're not talking about web scrapers that, let's say, need to spend hours on your website to get, your price lists, right? That happened like 10 years ago, right? Your competitors need to know your price. You run your e-commerce platform and they run kind of web scraper, and the web scraper, try to get all the prices, list your catalogs and get the prices. Nowadays, it's completely different. Nowadays, with APIs, they can consume your API very heavily, even with, 50 requests per second. With 100 items per request, they can download 10 million items in less than a minute. Think about that. So before that, it was hours. Nowadays, it's like a minute, right? That's exactly what they're looking for, right? That API make all the data accessible. And again, we're looking in the world of bandwidths like 5G, right? We're not talking about the internet, and connectivity speed as it was like years ago. So that's all contributes to one thing, right? And then the kind of like real-time nature of these attacks makes them very hard to detect, because many of the security controls applied, they built like decades ago, and they cannot block attacks in real time. They can detect attack in a couple of minutes, then send a signal somewhere, then the system make decision, then the blocking kind of rules or control start to roll it out, and overall you have 15 minutes, in sometimes 30 minutes or hour to make this mitigation done, and attackers only need less than a minute to get all your prices and all the data they need. That's the reality.
When it comes to security, once again, we go back to the point of, I covered security a lot, and one of the show I run with Akamai, CISO Insights, and he says that, culture can eat strategy and all those planning, for lunch and breakfast. So culture does play a very big role in security. And when I talk culture, I'm not just talk about employees sitting at the end devices, don't click on the links, make sure all the security processes are in place. But it also happens within an organization, within the security now security is also becoming a board level discussion. Now, when we look at all, not only how API expose you, how it makes you vulnerable, but also the mode of sophisticated attacks. Talk about, of course, tools are there, and we will talk about the company as well. But let's also talk about the importance, because if that I say, though, you can bring a horse to a lake, but you cannot make him drink water if he doesn't want to drink water. Same thing, with the tools. If you don't have right cultures, I mean, if you don't lock your car, it doesn't matter how strong armored those doors are, if you don't lock them from inside. So can you also talk about the role of culture, processes in order to build a very good API security posture? And then after that, a follow-up question we'll ask about the solutions which are available there. But let's talk about culture first.
Yeah, you definitely bring in good questions, which concern many companies across the world. The first thing, as like, and I usually start with that point when I try to explain the API security and specifically posture management to large companies and enterprises. So, and it's a very important point. Not only modern software, not only modern product using APIs, right? We are really talking about, and ultimately attackers always looking for low-hanging fruit. You're definitely right. In other words, let's say I have a system like SAP, right? SAP consumes SOAP protocol, right? Which is a legacy API protocol. But this is the first target for attackers. They will not try to hack your Kubernetes if you have some kind of SAP or other ERP system available, right? The same Salesforce, definitely the reason to get into is, it's reasonable, right? Because you have a lot of data there. By default, attackers know that all your data, your accounts, your customers, your invoices, right, goes to Salesforce, no matter what, right? The same as here. So the reality is the posture management should start with your data kind of prioritization. You have to know where your data is and which APIs consume the data, prioritize data first, and then find out all the connections through this. This helps a lot to prioritize your posture management and find basically the data connections, right? All these ways to connect, the world outside, your partners, your customers, some other companies, and also attackers, right? To you, the data that you want to secure. Once you have this kind of map, then your posture management works much better. The other thing is, and again, as I said before, so legacy software, legacy APIs, they're probably the first targets for attackers. They will very rarely to attack the most modern, REST APIs that you recently roll out through API gateways. They try to find out something else, right? The other thing is overall controls. And when we're talking about the posture management, I think the best way to compare it with the other part of security is the zero trust, right? The zero trust and implementation of the zero trust can help you to think about how this API security controls should be built, right? In other words, if you have someone that consumes your API, such as partner, you should not trust the partner by default. The partner can send attacks. That's absolutely normal. If you, roll out some kind of new mobile app and the mobile apps start to kind of spread through, very specific marketplaces such as iOS, 100% attackers will have an access and unpack this, reverse engineer them and extract all the keys and do everything. So you cannot trust your customers, even if they connect through, Verizon or some legit, and use some legit accounts. So absolutely the same approach should be applied there. Specifically related to the posture management, on top of them starting with the legacy and then you kind of the sensitive data first, you have to know not only how this posture look like from the from the internet, but also from the inside, because API security just multiply all this, internal security problems such as, bad actors and, malware, kind of, backdoors, right? They also can consume APIs from the inside, right? You have to know your posture, the API posture from the inside and from the outside as well. Specifically nowadays, when your inside became more and more open and more, accessible because of the AI, right? Many of the security controls were just broken because of the AI race. So they just need to connect all the data. And to do this, they need to break the security controls, remove firewall rules and, remove data isolation, stuff like that happening right now.
Now let's talk about the solutions that are available. Of course, we can also talk about Wallarm, and you can also talk in general where you see there are still some gaps, pain points when it comes to API security, where folks like you have to fill those gaps, or yes, the tools are available. Just give us a state of what kind of solutions are available, especially from you folks.
So first of all, and as I said before, right, our main goal to building the product was to actually block attacks and block it in real time. That makes us absolutely unique. We're not talking about 5 or 15 minutes. We're talking about real attacks that we have to stop right when they happen, right, in real time, so no delay. So that's absolutely unique thing that we built. So doing this, we also uncovered many other use cases such as, discovery and posture management, and now API attack surface management, which is kind of all the that collect all the available assets from the internet, and also get some OSINT, such as like scan for GitHub repos and some other things that these all tiny pieces contribute to one problem, right? The problem for the API security, because API keys is accessible. If you have a key, most likely you can consume the key. Very rarely key, somehow attached to the API addresses and so on. So that we try to connect the dots and build it all together. The main thing and the main problem we have to find out is how to do it at scale. And we're proud to have like large, the largest companies in the world using that in real time with the blocking, because we deliver this for them, right? Definitely requires some CPU, some RAM. That's not a magic in this point, but we can deliver it with zero latency, almost zero latency. Depends on like the network architecture, which helps a lot to actually stop real attacks. Our main focus is there. And the attacks for APIs, right, they adjust at race. And every single time when we run this threat set report quarter over quarter, we already did, I guess, 10 or 11 reports like that for the last, almost 3 years. We all the time see something new, something impressive. And unfortunately, some new data breaches happen, and the data breaches became more and more massive. And the main difference between this and why we need to do it real time is the data breaches, basically, as I said before, the data breaches based on APIs and API exploits, they're completely different on ransomware. It's hard to stop them, it's hard to detect them, and you know about them when it's already happened, but when it already happened, you lost an entire databases. That's why we're talking about things like, hey, where is this, all this social security numbers, how it was possible to download all of them because of APIs.
I want to go back to the topic that we talked about, AI and API security. As you earlier also mentioned, when it comes to AI, it's all about data. You have to pull data out in the bottom, all those things. Now, when I look at AI, and of course these days there's a lot of discussion around Gen AI as well. We can look at AI as a workload that you have to protect. At the same time, AI has been used within, for security, tools as well. So AI helping build security tools, at the same time securing AI workloads. How does Wallarm look at it?
Yeah, AI for us is kind of like two different problems. The first problem, how to secure this AI, because again, AI consumes APIs and we have to know what's there. We're not only talking about LLM, but large problem of AI, such as data governance, how to train the models and so on. And then we push in new features to basically stop more and more attacks like that. Plus, in real life, right, many of enterprise companies and our customers, they just consume some other AI, like an OpenAI or Azure or Microsoft AI or others through API, right? And then our tool help them to find out how much they consume, how to secure that stuff, and so on, because it's essentially the same API as others, right? Nothing new. The other thing is, and it's also help us a lot as using LLMs, like the general AI, to improve our own products, to first of all find new issues, right? Find some bypasses, try to challenge, and also find vulnerabilities in our code where we actually can apply LLM and AI and find some value. That's very interesting approach, and as well as like many other companies in cybersecurity and not in cyber, so we're doing the same. Interesting thing here is, unlike non-cybersecurity companies, right? All the cybersecurity companies now face with the other problem where attackers use an LLM or AI to attack them, right? The same approach, as I mentioned before, that we use internally, they easily can use it specifically with highly available product like us, so everyone can download the product, it's available, so we don't need to call, sales to get the product available, right? So, and that's helped us a lot to, build the trust, right? The product is ready, so you can find it and download and enjoy it yourself, right? So that's helped a lot, and it's also helped attackers. We know that they, try to consume AI LLMs to kind of like build this kind of automatic, exploits, automated hacking tools to cover. And even, definitely they mainly start with kind of low-hanging fruit, such as like bug bounties, right? Rather than, cybersecurity tools, because it's ultimately harder. But if you just look at the statistics, how many this cybersecurity products were vulnerable, and I'm talking about, Fortinet, F5, you name them, right? Many of these new exploits, you find that they also at risk. So basically attackers somehow, with the LLM or not, we don't know that, but what we see as it's more and more exploits that specifically point at the cybersecurity products that sitting on the front line, such as firewalls, network devices, right, from top cybersecurity companies, with exploits such as remote code execution, allowing attackers to basically get into your network through the security device, which is blow my mind. So I feel that this kind of like that we as a cybersecurity company as well as others became more and more interesting for attackers because now they are supercharged by AI.
Now, since we are talking about AI, we cannot ignore a lot of new use cases emerging. I mean, we cannot live in an AI, API, data-driven world. And one of the exciting use case these days is also electric vehicles, EVs. Uh, can you also talk about what are the new use cases that are emerging, which are also kind of keeping you awake at night that you feel like, hey, we have to protect and take care of these use cases as well?
Sure. And then to answer the question, I guess we just need to look around, right? Your vehicle most likely connected, right? Connected to the internet, right? Through the internet to the kind of mothership, right? So you need this to basically drive, right? If you don't have the data, you don't have a map, you don't have a new firmware, right? And an engine will consume some kind of previous generation of the settings, so that's also not good for you. So you really need your vehicle now to be connected to drive in the right way. The same all the other things around us, right? Connected devices, smart home, and more generic and more industrial, such as smart cities. Right now, the companies connect entire cities to data systems to manage them, find kind of like issues and manage them, right? This all things contribute to the API security a lot because we have kind of this API trace there, and no one even tried to build the security controls before, right? The use cases wasn't there, and then it happened overnight. So API security is well aligned with that because we're essentially doing this, right? We're securing these APIs, and this API just exploding. And I guess that you will agree with me that very, very soon with, kind of like lowering cost of the satellite launches, we will have more and more commercial companies running their own payloads in the space where they cannot patch them, they cannot update firmware easily, right? It is hard, they will interconnect and so on, they will all consume APIs. And these companies, they will not build this based on custom super secure communications. They most likely will basically use very generic APIs such as gRPC, REST, or GraphQL, right? That's the next for us.
Ivan, thank you so much for taking time out today and, of course, talk about this topic. Thanks for sharing great insights, and I look forward to talk to you again. Thank you.
Thank you.